How did theoretical breakthroughs lead to AGI? Imagine a world where machines can think, learn, and solve problems just like humans do. That's the goal of artificial general intelligence, or AGI. But how did we get here? It all started with some big ideas in science and math that changed how we see intelligence and machines. One of the earliest and most important ideas came from Alan Turing in 1950. He asked, "Can machines think?" and created a test to see if a machine could imitate human responses so well that no one could tell if it was a machine or a person. This idea set a clear goal for AI research: make machines that can reason, communicate, and learn like us. Before Turing, mathematicians like George Boole and Gottlob Frege worked on logic, turning reasoning into symbols and rules. Later, Bertrand Russell and Alfred North Whitehead tried to write all of mathematics in a formal way. This made scientists wonder if all thinking could be done by a machine. The answer came from Kurt Gödel, Alan Turing, and Alonzo Church, who showed that while some limits exist, any process that can be calculated can be done by a machine. This is called the Church-Turing thesis. It proved that machines could, in theory, do any task that a human brain can do, as long as it can be broken down into steps and symbols. These ideas opened the door to imagining machines that could learn from experience. In 1952, Arthur Samuel built a checkers-playing program that got better the more it played. This was a big step toward machine learning, where computers improve by practicing and analyzing data. Later, researchers created cognitive architectures, models that try to mimic how the human mind works, including perception, memory, and decision-making. These models brought us closer to machines that could think more broadly, not just perform narrow tasks. The rise of machine learning, especially deep learning, sped things up even more. Deep learning uses neural networks that can recognize patterns in huge amounts of data. For example, long short-term memory networks helped computers understand sequences, like language or music. Large language models, such as GPT-3, can generate text that sounds surprisingly human. They can translate languages, answer questions, and even write stories, showing how machines are starting to understand and use language in flexible ways. From the strange experiments of teaching machines to play chess or chat convincingly, to the quirky results of neural networks that mimic human quirks, these breakthroughs have shaped the path toward AGI. They gave researchers the tools to create systems that learn, adapt, and reason, key steps toward machines that can think as broadly as humans do. Every new discovery in this area pushes us closer to a future where machines might truly match human intelligence in every way.